All right. Okay. So today we're going to be talking about number patterns. And whenever we're talking about number patterns, we're actually describing a relationship. So I'm going to give you guys something a little bit more difficult than what we're going to be doing, but I want to see how many of you guys can catch on to what I'm actually doing here. Okay. So my first number that I'm going to give you is 5. I'm sorry, is 2. The next number will be 5. Then the next number is 1. And the next number will be 4. And the next number will be, well, let me see, make sure I got this right. Let's see. How many of us can pick up what I'm doing and what number is going to come next? Oh, the podium is at the end. Thank you, Shadi. That's lovely. Has anybody figured out how Teacher Coco got from one number to the next, to the next, to the next? Sorry, Indipili. We'll try and make this nice. Okay. Anybody? I'll give you a hint. Try adding and subtracting. Unati, tell me, what do we think?
Hi, ma'am.
Hello, my darling.
So you have to add 3 and then minus 4 and then add 3 and minus 4.
Oh, lovely, amazing. +3 minus 4 +3 minus 4, and you've got it spot on. Amazing work. That's exactly it. All right, and this is how patterns work. Now, patterns mainly are about recognition. Okay. Patterns are about recognition, and that's pretty much everything that we work with in life. Okay, the robots that work on the street. Okay, the robots that work on the street, they use patterns, right? We wait 30 seconds, and then we turn amber. We wait 10 seconds, and then we turn red. And then we wait 1 minute, and then we turn green, and then we wait 30 seconds, and then we turn amber, and then we wait 10 seconds, and then we turn red. So all of the things that we actually work with on a daily basis are kind of used off of a specific pattern. And that's why everybody's internet works, because everybody's internet uses the same kind of pattern. Yes, we're all going to different places, but every single code that is written in the way that you move your computer, in the way that you do anything, is because there's a specific pattern recognition that helps everybody to connect to the internet. Nipile, my darling, I see your hand. Do you have a question? Do you have a comment?
No, ma'am. I just wanted to answer before.
Oh, I see. Okay, my darling. I have many, many other questions. We're going to get to them in just a bit. Okay. All right. So what do number patterns actually do? So what they're doing is they're describing a relationship between two values. So there's always one thing happening and something else is explaining exactly what is happening. And we call these two values variables, and we're going to see how they work. And we've all heard this word variables. We've done algebra before, and we can see that. All right. Now, when we are looking at these particular patterns, there is always a constant pattern. Okay. In our case, when it's numeric, we are either adding or subtracting in order to figure out the constant pattern. Excuse me. Sure. My throat is doing funny things. Sorry, guys. Okay. So we'll have a constant pattern, or we can call it a constant difference. Okay, constant difference. Just like Unati's just told us about, we add 3 and then we minus 4, and add 3 and minus 4. And we call that a numeric sequence. We're going to be focusing on numeric sequence quite a bit in grade 8, and we'll get to geometric sequences in grade 10, 11, and 12. But we're going to be focusing on numeric sequences. Yeah, we'll just call them numeric. We're not going to change the name now. Otherwise, it's going to get super complicated. Or if we add or divide to get from one part to the next, we call that a constant ratio. It's called a ratio. And I'm going to explain why we call it a ratio as we go along. So now if we have to multiply and divide to get from one to the next, we call that a geometric sequence. And it's all going to make sense in just a little bit while we talk about it. All right. And then because we are describing something just like Unati just did in this particular question. She's describing for us, we add 3, we minus 4. We add 3, we minus 4. We need to be able to create a general rule for every pattern, or because this pattern is going to continue, we need a general rule that's going to kind of give us an overall idea of where this pattern is going, if it goes on forever, or whether it goes on to 100 numbers, or if it goes on to 1,000 numbers. We need to have a general rule that then describes every single pattern. And we write this pattern as an equation. We write it as an equation, and I'm going to show you what the equation looks like. Okay, then we can substitute input values into the formula to calculate output values, and I'm going to show you what that looks like as we go along as well. And to find the rule, we always look at the constant difference times the term number plus, and this little box that should actually be over here means a constant, and that will equal the output. But I will show you guys how to write this, because it's not as simple as we're thinking. Oh, this sounds very complicated. I'm going to make it a little bit simpler for you. All right, let's look at a quick example. So let's look at the example over here. The pattern we've been given is 3, 5, 7, 9, 11. Okay, who can explain? Describe the pattern for me. What are we seeing? Yes, Shadi.
Ma'am, you add 2 every time.
Good. We add 2 every single time. And I love that you've said that. But when it comes to patterns, we need to be very specific. Let me explain why. If you say we add 2 every single time, 4, 6, 8, 10, 12, I'm adding 2. Does that mean that that's my sequence? Have I got the right sequence, Shadi?
Ma'am?
Have I got the right sequence? That 4, 6, 8, 10, 12, is that correct?
Yes, ma'am.
I'm adding 2 like you said, but it's not exactly the sequence that we're talking about, is it?
Yes, ma'am, it's not.
No, it's not. So we need to be very specific. Where did my sequence start? At what number?
At 3.
Good. Excellent. So I can't just say add 2, because I'm also adding 2 here. Add 2, add 2, add 2. But that's not correct. That's not the one that we're looking for, right? That's not the answer that we're looking for here. Oh, and I need this eraser to work. Okay. So when we describe a pattern, we always need to start by describing where it starts. So Shadi, do you want to start for me again? Start by telling me, start at, what number do we need to start at?
You need to start at 3 and add 2 each time.
That's it. So when we describe our pattern, we have to say start at, and we look at the number that we start with and add 2 to get to the next number. All right, thumbs up. Everybody understand what we need to do here? Okay. Remember, it's very important that we describe it properly, because if we just write add 2, we could add 2 anyway. So we need to be very specific. Okay, so start at 3 and add 2 to get the next term. Okay, to get the next number. Okay, and we're going to call it a term. We'll chat about why it's called a term just now. All right, then the next question says, add in the next 3 terms. What would the next 3 terms be? Who's got the next 3 terms for me? Emiche, do you want to give me the next 3 terms?
Yes, ma'am.
Go for it, my darling.
So the next 3 terms are going to be 13.
Good.
15.
15, lovely. And
17, ma'am.
17, beautiful, excellent work. All right, so you've done the hard part. You guys have done the hard part for me. I'm now going to do the teacher part, where we talk about how to write this as a general rule. And I'm hoping everybody is writing notes or is going to take a screenshot, because what I'm about to do is very important. All right, so when we write a general term or a general rule, we always write it as TN. Oh, and I need my pen to cooperate. TN. All right, and then we're going to say that TN must equal dn plus c. Now, we are going to have to talk about what all this crazy stuff actually means. Sorry, my T is bothering me. All right, so let's start by looking at our pattern. All right, so if we look at what we've got over here, number 3. Number 3 is the very first number that we have. We call this number T1. What T1 stands for is for term 1. Okay. Now, what term 1 means is that we are looking for the number sitting in the first position. Okay. We are looking for the number sitting in the first position. So, because that tells us which number is sitting where, if I asked you guys, what number is T2? What would we say? Hold on, let me write this. T1 is equal to 3 because the number in the first position is 3. So if I said T2, what is T2 equal to? Which number is sitting in the second position? Which number is sitting in the second position? I see somebody named Razafin or Jolina. I'm not sure who that is, but if you want to unmute for me and tell me which number is T2.
5, ma'am.
5, lovely. And I don't want you to go away, Gloria. I want you to wait right there. I want you to tell me now, if I'm looking for each of these numbers, we know that T2 is 5. Can you tell me what T6 would be? What is T6?
Hold on, ma'am.
It's okay. I'll give you a second. It's going to be 13. Amazing. Good. It's going to be 13 because we're looking for the number in the 13th position. So this is number 1, number 2, number 3, number 4, number 5, and number 6 would have to be 13. Oh, beautiful. Excellent work, my darling. That's exactly the answer I was looking for. So we can tell that whenever we have T1, T1 would give us the answer of 3. T2 would give us the answer of 5. T6 would give us the answer of 13. But now, if you look at ma'am's general rule, I don't have T something. I have TN. Ma'am has written TN over here. Now, what TN tells me is whatever position we're looking for. Which term? Which term? Okay, thumbs up. Everybody understand why ma'am has put an N there? We don't know which number we're looking for yet. So we're just going to rewrite it as an N there because we're going to choose later on in the future whether we want the 20th term or whether we want the 50th term. Then we can replace N with 50, or we can replace N with 20, or we can replace N with any number we want. But at the moment, we don't know what that number is. So we're going to leave it as TN. All right, let's talk about D. Does anybody know what the D stands for? Who knows what D stands for? Gloria, is that you? I see Indipile's hand as well.
Ma'am,
Whose
it means
hand do I
different.
have? It means difference. That's it. Okay, Lakeisha, it means difference. Okay, let's talk about what the difference means. Or I'm going to be a little bit more specific. Well done, my darling. This D stands for the common difference. Okay, let's talk about what the common difference is. Okay, so when we look at, excuse me, the way that Emilke has explained our pattern for us, she said that we start at 3 and we add 2 to get from one to the other. But technically, in order for us to figure out what the difference is, what D is, we're actually working backwards. We're working backwards. Let me explain. Just give me 1 second. Okay, let me explain what I mean. When we are looking for a common difference, we denote it as D, we are actually going to take the term before and we're going to minus the term or the term after, and we're going to minus the term before. All right. So when I look for the difference, I'm going to take my second term, T2, and I'm going to minus my first term, T1. And that would give me 5 minus 3. 5 minus 3 equals 2. That's my difference. I can tell that that's my difference there. Now, if I did this, if I took the third term, T3, minus the second term, T2, I would get 7 minus 5, and my answer would still be 2. I could also do it with the fourth term and the third term, right? I can take 9 and I can minus 7, the fourth term minus the third term, and my answer would still be 2. All right, so my common difference is when I take the number after and I minus, because that's what difference means in maths. It means minus. So when I take the number after and I minus the number before it, and I get a common number again and again and again. Thumbs up. Everybody okay? Are we all okay with that? Yes? Lovely. Good. So the D stands for common difference. How do we find that common difference? We take the second term minus the first term. Or we take the third term minus the second term. Or we take the fourth term minus the third term. And that will always give us our common difference. All right. Then the C. Does anybody know what the C stands for? C stands for the? Let's think of all the words that we know. Yes, that's it, Uma. It stands for the constant. That's it, Ndupile. Lovely. It stands for the constant. And now the constant is a little bit of a weird one. And I'm going to try and explain it going back to that example that we were using just now, to show you why it's important that we find a constant, or that we use a constant in our calculations. All right, so remember when Emile was explaining to us that we add 2 to get from one number to the next, right? I could have easily started my pattern at 1 and then added 2 to get there, or I could have started at -1 to get there, right? I'm still adding 2 to get from one term to the next. So in order to make sure that I start my my pattern at the right place, to ensure that I start my pattern at exactly 3, I will add into that a constant. I will add a constant so that my first term is always the first number that we see in our example. All right, and here's how we're going to find that constant. All right, what we're going to do is we're going to take our sequence and we're going to find, this is the first term, right? This is the second term. This constant over here is always going to be our T0. We call it the 0th term. And this might be a little bit different from the way your teachers teach you, but this makes so much sense, grade 8s. Just listen to what I'm saying. All right, let's think about this. I know that to get from 3 to 5, I needed to add 2. How do I go from the first term backwards? What would this number over here be? What number would I get over there, guys? That's it, Uma.
Yes.
Absolutely. We would get 1. Good. So because the number that we're looking for over here is 1, our constant C is also going to be 1. So that is the answer we're looking for C. C is 1. All right. And I know it sounds complicated, but let me show you what happens when we put all of these things together.
Ma'am,
All right.
can you please repeat?
Okay. So if we look at our sequence, right, we
Yes, ma'am.
know, I'm writing a lot. I feel like I'm muddying up the screen. All right. We know that the number 3 is our first term. Are you in agreement with me? That is T1. Our first
Yes,
term is
ma'am.
3. Yes?
Yes, ma'am.
And our second term, T2, is 5, right?
Yes, ma'am.
If I were to move, I would be at the 0th term. I would be at T0. What would T0
Okay.
be?
It'll be 1, ma'am.
1, correct. It's 1. So this 0th term that we have over here, we are going to take this exact number and we're going to put it as C, as the constant in my formula. Okay, does that make
Yes, ma'am.
sense? Can I show you how to actually make it work? Let me show you how we make it work. All right, so I'm going to replace two things in this particular question. I'm first going to replace the D. I'm going to replace D for the common difference, and I'm going to replace C. Now, I can't replace N. I can't replace this N, and I can't replace that N. And the reason I can't replace them is because I don't know which number I'm looking for yet. So until I know which number I'm looking for, I'm only going to replace the D and the C part. So my formula is going to look like this. It's going to say Tn is equal to, my common difference was 2, so I'm going to go 2n plus 1. All right, that's the
That's
answer.
your rule.
That's the general rule.
This one.
Okay. All right, so let's test this. Let's test it. Let's say we are now looking for T. Let me move up a little bit. Oh, just give me 1 second, guys. I just need to toggle so that I can move my screen. Otherwise, it's being difficult. All right, there we go. Okay, so my formula says Tn is equal to 2n plus 1. Right, now if I'm looking for the first term, remember we said T1 is equal to 3. Now you'll note that I've replaced n with the number 1. Thumbs up. Is everybody in agreement with me? I've replaced n with the number
Yes, ma'am.
1. See it? So that means in my formula, wherever I see an n, I'm going to replace it with the number 1. Let's go ahead and do that. Right, so I'm going to go T1. Oh, I don't know what happened there. I need my screen to move. Sure, guys. My screen is doing really funny things today. Okay, there we go. All right, so if we write this out, we're going to say T1. Oy. All right, guys. I don't know what's going on. I don't know what I've done to upset the stylus gods, but hopefully they will hear my plea and they will allow me to do my work. I thought this was an infinite screen and we could use it. Okay, let me see if I can write over here. Let me move the screen down and then we'll come back. Okay, I'll just have to write over here. I'm sorry, guys. This thing is being quite finicky. All right, so there we go. Please, please work. Oh, guys, technology is not my friend today. All right, so we said our formula is Tn is equal to 2n plus 1. Now, if I replace n with 1, I'm going to get T1 is equal to 2, and there's an n, so I need to replace the n with a 1, but I'm going to put it in brackets because 2n together means they're being multiplied. So 2 times 1 plus 1. 2 times 1 plus 1 will give me 3. And that is in fact true. If we look back at our formula, at our pattern, I don't know why this thing is fighting me so much. Okay, sure. My whole screen is just not doing the right things. Oh, guys. Okay, so if we look at our pattern, we can see that term 1 was indeed 3. Okay, and I'm going to try and fix this mess. I don't know what's going on with my screen, but hopefully we'll be able to maneuver this and it'll be fine. Oh, guys, I'm going to give up. Let me see if I can do this. I am going to take a screenshot of all of this, and then I'm going to put it on my own personal screen, and then we're going to continue from there. Otherwise, I'm not going to get anywhere. Okay. Let's see if I can do this quickly. All right. In the meantime, I want you guys to try for me. Try to find me the answer for T5. Please find me T5. Okay, use the formula. Here's the formula over here. And you'll see that we've replaced n with 5. And you can pop your answers in the chat quickly. Okay. Pop your answers in the chat for me, and then we'll get started on the next question. Just going to take a screenshot of this. Move over here. See if you can do things a little bit differently. I feel like this will be much better. Okay, lovely. All right, what answer did we get, peeps? You get 11. Good. All right. Okay, T5 equals 11. 2 times 5 plus 1 must give us 11. All right, please just make sure that you're putting the right things on the screen instead of don't do the wrong things. Okay, let me also take a screenshot of this, and then we'll go use it on the other screen because this screen is just giving me too many hassles. And I like my own screen a little bit more than I like this one, I'll be honest. Paste. All right, okay, let's go do these next examples over here. Okay, I'm going to stop sharing my screen for 3 seconds. Stop presenting. And move over to this other screen here. That's okay, Kielebocha. It's perfectly fine, my darling. We're all learning. All right, give me a thumbs up. Can everybody see the new screen? Yes? No, not yet.
Ma'am, I can see it, but it just took time on my side, but I can see it.
Okay, lovely. Thank you. All right, I did see the thumbs down, but it's finally on the screen. All right, thank you very much. Lovely, lovely stuff. All right, guys. So let's go look at this example over here. Let's look at example B. I can flip my screen back and it should work. It should work to my advantage. All right. So let's remember the general formula, right? We know that our general formula is going to read Tn is equal to Dn plus C. I need someone to remind us, what does the D stand for? What does the C stand for? Anybody remember?
Common difference and constant difference.
Good. Okay, you're right about the common difference part, but then it's not the constant difference, it's just the constant. But love it. Thank you, my darling. Absolutely, that's it. Okay, so it's the common difference, that's the D, and the C is the constant. All right, so let's start by figuring out what the common difference is, right? So remember, when we find the constant difference, the common difference, we will take, this is T2, and T2 is equal to 1, and T1 is equal to 4. So if we want to find the common difference, we're going to take T2 minus T1. So our common difference is going to equal 1 minus 4. What is 1 minus 4, grade 8s?
3, ma'am.
3, ma'am.
Ooh, 3, not 3. Remember, if it was 4 minus 1, it would be 3. That's it, Bree. That's the answer I'm looking for. Kielebocha, I know you've got the right answer for me. What is it? Negative 3. Good. Remember, you need to use your number line. It's negative 3. So my answer is negative 3. And also, if I take T2 or T3 minus T2, if I take common difference, if I take negative 2 minus 1, that will also give me negative 3. Right? If I take T4 minus T2, that will also give me negative 3. So my D, my common difference, is negative 3. All right, thumbs up. Everybody okay with that? We all good? Lovely. All right. Who can remind us, how do we find C? How do we find the constant? What do we look for? The what term?
Ma'am, can I please go to the bother?
Yes.
The 0th term.
That's it. Lovely. The 0th term. Ah, beautiful. We've learned some really, really fancy maths today. So we want T0. That is our constant. T0 is our constant. Now, remember, when we go that way, we need to minus 3 minus 3, minus 3. If we're going in that direction, what are we going to have to do? Indipile, do you want to tell me? Instead of minusing 3, because now we're going backwards, what are we going to do?
Add 3.
We're going to add 3. Beautiful. Uma, do you want to tell me what that number is going to be? What is the constant?
Ma'am, the constant is going to be +1. Yes.
Not plus 1. Remember, we're not minusing. We're going in the opposite direction, so we must plus. So we're going backwards. All right, so we're looking for the number that goes here.
So if you add 3 to 4, you're going to get 7.
That's it, 7. That is our constant. 7. Beautifully done. All right, amazing. So we've got the two things that we need. We know that our common difference is -3 and our constant is 7. That's our constant. But let's I'm getting ahead of myself. Let's do our due diligence. All right, who wants to describe the pattern for me? Leago, would you like to describe the pattern for me?
I'm shaking, ma'am, because I'm lagging, ma'am. I can't hear you on my side.
Okay, all right. It's okay. Do you think you can describe the pattern for me? I'm hoping you can hear me a little bit clearer. Can you do this part for me? Describe the pattern.
Shaking, ma'am, I can't hear you.
Describe the pattern. Can you answer this question for me? Describe the pattern.
Ma'am, are you still there? I can't hear you.
I am. Oh, guys. Okay, Leago can't hear me. Does anybody want to help him? All right, Leago, we're going to come back. We'll come back to you. Gloria, do you want to help me with this one?
Yes, ma'am.
Thank you, Uma. Yes. All right, my darling.
-3 from 4.
We need to start in a specific
you
way.
start-
We say
You start from 4 and -3.
that's it. Start at 4 and -3. Good. -3. Good stuff. Amazing. All right. Let's talk about the next 3 terms. Who's got the next 3 terms for me? Indipile?
Hi, ma'am. So our next 3 terms, ma'am.
Mm-hmm.
Oh, ma'am, I'm so
It's okay.
frustrated.
It's okay. Do this very quickly in your head. I do this. I do that in my head. -1, -2, and then I just start counting. Because I'm minusing, I know I'm going to move in that direction. So let's go from -5, move in that direction 3 times. Where would we land?
So it's -8.
-8. Lovely. That's the first one. What's the next one after that?
Negative
Keep going. Backward.
-11.
That's it. -11. And then the last one?
-14.
Oh, beautifully done, my darling. See, it's not that difficult. You just quick number line, and you got it. Well done. Amazing work. Amazing stuff. All right. Phew. Excellent work, guys. All right, good. So those are my next 3 terms. My next 3 terms, -8, -11, and -14. All right. So, Uma, I can see your hand is still up. So I want you to move us again.
Ma'am,
So I'm gonna say Tn is equals to Dn,
Lovely.
and I want to test it first. That's how I learned it. So we test, and then we find out the difference by adding something to the test. So yeah.
Okay. All right. Okay. So what we're going to do, Uma, which I'm gonna be honest, is a little bit easier. Okay. We're gonna take the 2 numbers that we've already found. Remember, at the very beginning, we found our common difference and we found our constant. So basically, what we're doing is we're just substituting in. When we're testing, then you can pick whatever number you want to test with. Does that make sense?
Yes.
Yes. Okay, so I just want you to replace the values for me, please.
So I'm gonna say Tn is equals to -3 n plus 7.
Good. We don't know what n is yet. Good. Plus 7. Lovely. Amazing. Now, go back to our sequence. Pick any term you want. Remember, this is the first term, this is the second term, this is the third term, this is the fourth term. Pick any of these and let's test it. Which one?
Term. Can I pick higher than term 4?
Yes, of course.
Term 6.
Term 6. All right, lovely. So we're going to replace n with 6. Can you do that for me?
So Tn is equals to -3 times 6 plus 7.
Plus 7. Lovely. All right, let's do quick math. -3 times 6 will give us?
Minus 18.
Good. Minus 18 plus 7. Quick math.
Minus 11.
Minus 11. And would you know it? There it is. Nipile had found it for us earlier. And do you see how our term now works? Yes? Well done, dude. Amazing work. Amazing. So we put the numbers in and then we use those numbers to test. All right. Let me see. Can everybody give me an emoji? How are we feeling about finding the general term, describing the term, and finding the next 3 terms? Are we all good? Because I want to give you guys an example to try on your own. Yes, my darling.
I still can't understand how you get a constant.
Oh, the 0th term. Okay, so
Yes,
I can
ma'am.
give you like the long explanation about how we get there. Okay, the 0th term is the easier way to do it, but I'm so happy to explain the long way. All right, okay, so let's do this. Okay. Okay, that particular question is a little bit more difficult, but okay, let's do this. If I give you the sequence 3, 7, 11, 15. All right. Okay. What's my common difference here? How do I get from 3 to 7 and then from 7 to 11 and then from 11 to 15?
I plus 4.
Good. We plus 4. So we know that our common difference is 4. Okay.
Yes.
Now, if I do this, if I go Tn is equal to just 4n. If I just say 4n, right? I know that if I replace this with my first term T1 is 3. So if I do this, if I go T1, that's going to equal 4 times 1. My answer is going to be 4. So your constant or your common difference is not wrong. It's just that the answer it's given me is not the number that I started. So how do I get from this 4 to that 3? What would I do?
I minus
We would
1.
minus 1. Right, we would minus 1. Okay, we would minus 1. So my general formula is actually 4n minus 1 because I need to minus 1 to start at 3. So 4 minus 1, which will give me 3. All right, but now this minus 1, I could easily get if I just took my common difference and I moved it that way. So if I took 3 and I minus 4, I'm going to end up at minus 1.
Yes, ma'am.
Okay, so the 0th term does the same thing that finding where our T1 needs to start is. Okay, you see what I mean? And it will work for every single term, As long as we find the 0th term, we'll be able to work with it. All right.
Yes, ma'am. Yes, ma'am.